Welcome to Geometry. Let's review what you've read in Chapter 1. The definition of a set is any collection of objects. In your book, they picture a bunch of objects that you might have related to your cell phone. We use capital letters and braces to name sets. And when you're drawing these braces, make sure that you don't use a parentheses. A set can be named by using a list of items or by using set builder notation, which is a method to shorten long lists. Inside of those lists, you're going to have elements or members. Elements are objects in a set. We write the symbol E, I call it a rounded E, to signify element. Let's take a look at example 1 on page 2. Describe set P. Those are the pictures of the cell phone items in your book, using both the list method and with set builder notation. So under the list method, we have a phone case, earphones, screen protector, car charger, battery, sync cable, and armband. Using set builder notation, we can shorten that. And we write set P equals, using braces here, X, such that X is one of Liam's cell phone accessories. This makes listing sets much more usable. The slash here is as such that. One of the things you should know is that you can list your elements in your set in any order. So let's apply this. We have sets A, B, and C. A equals numbers 1, 3, 5, 7, and 9. B equals 3 and 7, and set C equals X, such that X is greater than 0 and less than 10, and where X is an odd integer. I always like to break these down so that they make sense to me. And if I break down what this says, it's an odd number less than 10 greater than 0. That would give us 1, 3, 5, 7, and 9. Let's go ahead and pause, and we're going to work on problems 2 through 6 even in your homework, and problem number 7. After you've completed those, come back to the recording. Now moving on with sets, let's talk about equal sets. Sets with the same identical elements. So let's look at those sets we saw before. A had 5 elements in it. They're all odd, and they're all less than 10 and greater than 0. Remember that C was also the same amount of 5 elements, all odd, less than 10 and greater than 0. So these sets are identical and they're equal. So your answer here would be A equals C. Subsets. A subset is every element in B that is also in A. So let's take a look at B. B are the numbers 3 and 7. 3 and 7 are also in A. So you could answer this, B is a subset of A, or you could say A is a subset of C, because we have already identified that A and C are equal, and equal sets can also be subsets of each other. Another definition is the definition for the proper subset. This has a symbol that looks like a stretched out C. If you remember, the subset was that stretched out C with a line underneath, which means equals. Your proper subset does not have that line underneath. It is more specific. Since every set is a subset of itself, we know that A is a subset of C. We just explained that on the last slide. But it is also an equal set. We had determined that first, that A equaled C. To be a proper subset, the set would contain original elements of the set, but not be equal to the set. So B is a proper subset of A. B is a proper subset of A because it contains two elements from A. It contained the elements 3 and 7 from A. Proper subsets will have at least one element less than the original set. So this means that in the first set, we had 1, 3, 5, 7, and 9. For set B, we had 3 and 7. We could have a set that had 3, 7, and 9, and that would also be a proper subset. Besides having equal sets, we also have equivalent sets. And these are sets that have the same number of elements and are in one-to-one correspondence. That means that each item in one set compares to one and only one item in the other set. So these would be sets. I'll give you an example. Set A contains elements 1, 2, and 3. And set B contains elements 4, 5, and 6. None of those elements are copies of each other. However, both sets have 3 elements, so they correspond one-to-one. That means they would be equivalent. The empty or null set is always a subset of every set. And you've learned about the empty set before in algebra. The empty set sign is the 0 with a line through it. So the empty set is a subset of set A, or set B, or set C, or every set that you encounter. Here is examples of some of the symbols that you're going to find in your book. It's important that you understand these and use them when doing your math. Let's take a look at example 2 on page 3. We're given 3 sets, A, B, and C. These are the same sets we've used previously. Let's answer some questions about these sets. A. Set 1 is an element of set A. Is this true or false? Well, it's false, because the 1 is not an element. It's a set unto itself. Let's look at B. Is A not a proper subset of C? Well, A is a subset of C. We've talked about this previously. Because A is an equal set with C, they're also subsets of each other. But it is not a proper subset because of the fact that A equals C. So proper subsets cannot be equal sets. Let's look at C. B is a proper subset of C. True, we've already talked about this. All elements of B are in C, and B is not equal to C. So this is the difference. B is not equal to C, but A was equal to C. And the last one, B is a subset of the empty set. That's false. Neither element of B can be found in the empty set because it's empty, so it has no elements. Sets can be added and subtracted. We call these set operations. Operations like addition and multiplication can be used with sets. When doing these operations, we have some definitions that we need to learn. First, we have union. And union is a funny stretched out U. That's a set that combines all the elements of given sets. So for sets A and B, if you wanted to add them together, you would use the symbol for union. This symbol here is the symbol for intersection. This is the set that contains the elements that belong to each set. They're the elements in common. Think back to greatest common factor, when you would pick out the multiples of a number that both numbers had in common. Examples. U, or the universal set, is the set of whole numbers. Let's look at some sets here. We have set A, 1, 3, 6, 9, and 12. Set B has the elements 1, 4, 8, and 12. And set C has the elements 0, 5, and 15. Using set operations, let's answer some things. A is in union with B. So union means to add together or combine all the elements. So we would add 1, 3, 6, 9, and 12, and 1, 4, 8, and 12. Even though both sets have 1 and 12, we only write the number one time. So A in union with B would be all the elements of the given sets. Now let's do an intersection. A in intersection with B, and let's take a look at what we'd see. We need the sets of numbers here that are the same in both sets. So we've determined this previously. A has a 1 and a 12, and so does B have a 1 and a 12. And we list those in the sets, and these are the elements that are in common. When I have set operations like this on my paper, I always circle the items in common, making it easier to identify the sets. And last, let's look at this. A in union with C. So we would add the set A and C together, being careful not to repeat any numbers. A in intersection with C, making a comparison, all the elements in A and all the elements of C have no repetitions. So there are no numbers that repeat each other, so we have an answer of the empty set. If the sets have nothing in common, they are called disjoint sets, and the answer will either be the word disjoint, the symbol for empty set, or you can also use empty braces. So A in intersection with C was the empty set, and B in intersection with C is also the empty set. Go ahead and do your homework problems 13 and 17, 18, and 19.